All right, so picking up right where we left off, we're jumping into betweenness of points. And I will admit, pausing the video here, actually, I was just stumbling over my words. Betweenness of points, kind of a interesting concept. It's hard to put into words, honestly, but when you see it visually, it seems to make a lot more sense. So the words that we're going to use to describe betweenness of 2 points are that for two given points, and I'm going to use A and B as example points, there exists a third point between them that is greater than A and less than B. And basically that's just a definition of being in between. It's just saying that one is less than or to the left and one is greater to the right of it on a number line. Okay, so nothing crazier than that, but let's just do a quick example here. So if I were to write this out, if we had A and B, and let's put in, I don't know, point C. So this will be our between point. So it's between A and B. Let's check our definition here. Is it greater than A? Yes. Is it less than B? Yes. Okay, so on a segment, this works for us. So that might seem obvious, and you might be like, Mr. Eden, why are we taking the time to define this? It's actually going to help us with some properties to end up solving some questions here. So point M is between points P and Q if and only if P, Q, and M are collinear. So they have to be on the same line, and it also has to make sense as a property. So the pieces must add up to the whole is basically what PM plus MQ equals PQ is saying. So if we want to label this 1, 2, and 3, all that this is saying is that 1 plus 2 adds up in total to give us segment 3, which just as a definition is 100% true. So that's what we're looking for there. So all it is saying is that you can split a line, and if you add up the parts, it'll be the same thing as the whole. Okay. So now time to jump into our practice for this one. That's the wrong page there. I apologize for that. So we're going to start off with solving this first one. So it's asking us to find what is LM. So what is the segment from here to here? And this is the same idea as before. So our whole is 4 centimeters. Our part is 2.6, and we need an additional part to add up to the 4. So if you want to structure it like this, I would say part plus part equals whole. And let's take what we already know. So we already know that the whole is 4. We already know that a part is 2.6. So we're just looking for the hidden value here. I'm going to use x, and x is just going to represent something that we don't quite know yet. So we can organize this as an algebraic equation now. So x plus 2.6 equals 4. We can take the inverse of 2.6. So subtract 2.6 from both sides. Got to maintain balance because we got that equal sign there. 4 minus 2.6. It's all right if you need a calculator for that. I know that decimals can be a bit tricky. 1.4. Positive 2.6 and negative 2.6 give us 0. So we're left with x plus 0 equals 1.4, or x equals 1.4. Now, if I want to go back and see if this makes sense, I can say that my part is 1.4. And if I add part of 1.4 plus 2.6, I do in fact get 4. So I want to say LM equals 1.4. And notice when I'm writing this, I'm not putting the line on top because this is the measure, the calculated value. Okay, so that's the idea. So you can apply that same process to the remaining questions on this page. And I would say use the same framework. Part plus part equals whole. And sometimes you'll solve for the whole, sometimes you'll solve for a part, but either way, that's going to help you out. If we look at example D on the bottom, we're going to see some variables that are given to us here. So we're going to be getting into a little bit more of algebra. Okay, so in these types of examples, you're going to have a little bit more algebraic solving, but that part plus part equals whole, that does not change. That doesn't go away. Okay, so if we wanted to just take a look at the setup of this one, So part plus part equals whole. And I'll even write a little p and w down there. We have ut is one of the parts, so 5x minus 3. Another part is 7x, and they're telling us find x, give st and t between s and u. So st equals 7, check, that's there. su equals 45. Su, that's our whole. Okay, so we can plug that in right there. And then tu, 5x minus 3, we have that plugged in. All right, so we used all three measures. So here, now we can go through, we can start solving, and eventually we'll get that x value that we're looking for. Okay, so that setup, organization here is key. As long as you're solid with that, you'll be good to go. All right, next concept, and our last one for today. And again, I know that I'm going probably a little bit quickly here. Just know that you can pause the video, you can rewind the video, you can set this at a slower speed. Whatever pace is best for you is fine with me. All right, last definition is congruent segments. And this definition, hopefully a little bit more straightforward, a little bit shorter, honestly. It's just segments that have the same measure. So again, the idea for this is they are exactly the same length. So if we had something like LM and then PQ, if these are exactly the same length, we're allowed to say that they are congruent segments. If we had something like WX and then like YZ, a little bit smaller here, these are not congruent because they're not the same length, okay? So this is a not example. All right, so how do we write this? So two ways that we can do this. If we put a little dash, usually it's a red dash if there's color. So these matching red dashes say congruent. Sometimes you might have 3 red dashes. As long as this one has 3 and this one has 3, it's okay. So as long as there's usually like a mark like this, that'll tell you that they're the same length. The second way that you can write it out is it would be LM equal sign with a little squiggle on top. And that's just the way that we say LM is congruent to PQ. All right, so notes on the bottom here, 2 segments having the same measure are congruent. The symbol for congruency is just an equal sign with our squiggle on top, okay? And that's just saying that they're congruent. Here, you're gonna notice that they have the mark, and that's telling us that they're the same, and you'll notice our measures, yes, they are in fact the same. It is 2 centimeters. So that works for us. This is good, we're happy. All right, so let's go into some examples now. And I don't like red, I'm gonna go back to green. So our top one here, just asking for some identification. So your job in this one is just look which ones are the same. So you'd want to be like, okay, 14 and 14 are the same. So I could say that I'll put 1 dash here. Those are the same. Okay. And if I want to be really clear, I can say segment AB is congruent to segment AD. Another example, got 2 10s here. So 10 is not the same as 14. So actually for these two, I'm going to put 2 dashes. And that's going to say, hey, both of these have 2 dashes. They are the same length, but they're not 14.4. Okay, so an example for that is BC is congruent to DC. All right, so this is not all of the answers to this one. This is just a start. So if you want to keep going, let's put down a few more congruent measures here. You should see a couple more before we finish. Another example for number 2, I do want to take a moment just to touch on this one. So it's saying overall our whole is 4.8. And it looks a little bit weird, but S is actually giving us our part and our part. Okay, these dashes, that is a symbol for congruent. So we know that both of those are exactly the same. So we can say, okay, part plus part, which is exactly the same, I'll just call it X, equals our whole of 4.8. Or we could also say 2 parts of the same measure, or 2 X's equal 4.8. You're going to notice it's going to be exactly the same thing. If you add 1x plus 1x, you'll get 2x, but 2 different ways to see it. And either way, we can just go through and algebraically solve. So 2 divided by 2 gives me 1x. 4.8 divided by 2 gives me 2.4 for that answer. So I did want to go over this one more specifically, a little bit more of a challenge, but one that you're more likely to see when you go through solving these. So that's going to be it for today. What you're probably noticing right now is we took some definitions, but we also did some calculation today, so a pretty good mix. So know that algebra is coming up a little bit here. We're doing some solving. Any questions, need any resources or help, as always, feel free to reach out. Thanks for tuning in today, everyone.